So we're going to work this problem. It's problem 70 from section 4.1. Suppose that at any given time, t, in seconds time, the current I, in amperes, in an alternating current circuit is I equals 3 cosine t plus 3 sine t. What is the peak current for this circuit? The largest magnitude. So peak and magnitude, that's going to let us know it is a max. So in order for us to do this problem, we're going to need to find the derivative. So we're going to take I equals 3 cosine t plus 3 sine t. And we want to differentiate with respect to our independent variable t. So I'm going to take this and take the derivative with respect to t. So that gives me di dt equals 3. The derivative of cosine is negative sine plus 3. The derivative of sine is cosine. So the max or min is going to occur when this derivative I prime is equal to 0. So I have negative 3 sine t plus 3 cosine t. So I'm going to set this equal to 0, my derivative equal to 0, and then we would just solve for t. And once I get that t is time, that's going to let me know when the max is occurring. But if you pay attention to the question, it says, what is the peak current? So we need to find the current at that time. So in order to solve this, I'm going to move that negative 3 sine t over. I've got positive 3 sine t equals 3 cosine t. Divide by 3 on both sides. I've got sine t equals cosine t. And so where are sine and cosine equal? And that would be at t equals pi over 4 radians or 45 degrees. And in fact, it's at every pi over 4. So we could write our answer t equals pi over 4 plus pi k. And we would, of course, just say, well, k is some integer. So adding or subtracting pi is going to get us to one of those values. So if I want to finish this problem, I'm going to go back up and plug pi over 4 into my original equation. So I is equal to 3 cosine of pi over 4 plus 3 sine of pi over 4, which is cosine and sine at pi over 4 are root 2 over 2. So I have 3 root 2's over 2's. So that is 6 root 2 over 2, and the 6 and the 2 reduce. So I've got 3 root 2, and that would be 3 root 2 amps. So that is the current at the max. So the derivative tells us where the max or min occurs. But if we need to determine something with that function, we need to plug it back in to the original problem.